Howdy and welcome back. So we're going to continue our discussion on informal testing and debugging. Specifically, we're going to look at how asserts can be helpful towards this end. So asserts. In order to use these, you're going to need to pound include cassert. This is where they live. This is where they're defined. So in order to use them again, make sure you pound include this library. C asserts are going to be inherited from the C programming language. They're going to be used to evaluate an expression, and whenever that expression evaluates to false, your program is going to be terminated immediately. When the result is negative, the program will print an error to standard output with the file name and line number where the assert failed. And by negative, I mean false, and I probably should have used consistent terminology. So one of the cool things about these asserts, and I'll show you how to use them here in a moment, is that we can disable them through the compilation task. So we might have kind of a debug program where all of these asserts are going to be included. And then let's say we're ready to release it. Our release version could be compiled such that all of our assert statements are left out. So where might you use asserts? Well, when you write a program, insert some checks that variables have reasonable values. And the idea behind this is to kind of go through and as you're writing, consistently check to ensure that your expectations of what's happening within the program are actually occurring, that everything that you're considering is happening truly is. And maybe not everything, but again, the idea here is that to reinforce that your expectations are indeed being met. So let's say, I don't know, this is kind of a silly example, but maybe we're dealing with a collection of data and we have the number of elements in that collection stored in some sort of number of elements. Let's say for the sake of the application or context where we're using this, we're expecting that collection of items to grow to be no more than 1,000. So the largest reasonable size of, say, maybe this vector that we're using is 1,000. So these are our assumptions at this point in our program, and we can go ahead and write assert statements to ensure that, hey, these variables and that these take on kind of the expected values, or in other words, that our expectations are being met. So all we have to do after we've pound included cassert at the top alongside all our other header files is write assert, and then within its parameter list, you'll have the expression that you would like to be evaluated. In this case, my assumptions about this fairly simple blocker code is that, hey, the number of elements inside, again, let's just assume it's a container, is going to be less than or equal to 1,000. This assert passes because, well, -1 is less than 1,000. My second assert, in this case, is actually going to evaluate to false, that expression there, meaning that it's going to be an example of how the program terminates and what sort of feedback you can expect in the case that one of your assert statements has indeed evaluated to false. So I'm assuming that the number of elements in this collection of elements is going to be greater than 0. I think that's fair. It goes back to our area example where you wouldn't expect to have, a negative number of elements in a vector. It's impossible, just like, well, unless there's a bug, it's impossible, right? Just like we wouldn't expect our area to be measured negative, because that would, obviously communicate that something's wrong somewhere. A negative area doesn't make sense in our physical universe. So in this case, number of elements is actually less than 0. In this case, our assumptions are violated. We don't have at least one element at this point, and we thought we would. So due to this, the assert's going to terminate our program, tells the name of the executable. Here mine's a.out, tells us the source file where the assert was triggered, as well as the line number, tells us the function for some more information, and then it says that the assert that failed was the one that compared negative number of elements to 0. And it just clearly communicates this. And at this point, we can run up and begin moving backward from this point of error and see whether or not we can make sense as to what's going on. So asserts can also be helpful to ensure that post conditions are met. Perhaps there's some areas where it doesn't make sense to use an exception to verify that that a computation was performed, say, correctly after the fact that we checked the actual input to this function. So we started out with valid values. The user's obviously using this correctly. So we don't necessarily need to report anything back to them. So at this point, if there's an issue, it's kind of a product of our implementation and not necessarily the result of something that occurred on their end. So at this point, past this line, I'm assuming that this function would calculate the square root and that it would do so correctly based on the input, again, assuming valid input. Right here, I've just put in some of my expectations that I want to confirm before my function returns. At this point, I've calculated a square root, provided some sort of positive double value was entered. I would go ahead and write assert and say, I'm really expecting this result to be greater than or equal to 0. Okay, cool. Now let's say that somewhere in my implementation, I had a wrong calculation, the result became negative. Who knows why, but this assert statement would catch that. And if I'm in debug mode and I've kept my asserts in my program, I get this nice message that would say, hey, in driver.cc line 12, your essential within the square root function, an assertion failed, that which was looking at whether or not your result was greater than or equal to 0. And again, the cool thing is once I've done sufficient testing, I can actually compile and not include all these asserts in the production program if I didn't want to. And why might you not want to? They can slow it down because it is overhead in making all these additional comparisons. And depending on how much you have in your program, a small number can eventually add up to a large number. And it's a lot of kind of extra steps. So the cool thing with asserts is that they can easily be disabled, which means use them to test as many properties as you can, use them frequently, and use them adequately. We can always run the program in debug mode with all of our assertions enabled. Likewise, we can go ahead and run in production mode with the assertions disabled. So one thing you might be wondering at this point as well, when would I prefer an assert over, say, an exception? Asserts are going to help us detect programming errors, and I'm kind of focusing on right now as using them to look for logic errors, so errors made by us, the programmer, things that aren't meeting our expectations and not necessarily scenarios where we'd want to separate some sort of error handling from error reporting with respect to the actual end user of our library or code base. So there are situations where we cannot prevent errors from occurring. For instance, trying to open a file that doesn't exist, incorrect, invalid arguments passed to our function. But at the end of the day, it's kind of a lot of these scenarios where we're receiving input from some sort of external location where provided correct inputs, our block of code would execute correctly. However, because we did not receive valid inputs in some way, shape, or form, an error arose. In these scenarios, exceptions are perfect because the underlying algorithm implementation, we would hope at that point, is correct. It's just there's some sort of issue in terms of not having the right data to operate on or otherwise. So oftentimes it's going to be more practical to accomplish the task and check for exceptions along the way. And these were examples that we gave for. This is going to be particularly true in any time where we need to separate the error reporting from error handling. For instance, a prime example of this is that at function where we can begin to index into some location at a standard library vector. That algorithm would always return the correct element provided. I mean, it's been tested and true. However, if we're provided some sort of data that is, say, outside the range, that is not a valid index into our vector, well, in that case, it's more appropriate instead of just having an assert, terminating the program, is to actually notify the user and say, hey, an exceptional case has occurred. How would you like to handle it? And leave it up to them.